Right, year 10. This is lesson number 4 on radioactivity. So today we're going to look at what happens when those unstable elements try to become stable. And we're going to look at some decay today. So there are two different types of decay that we're going to focus on, and that's alpha and beta decay. And in this lesson, we're going to look at alpha decay. So I'll talk you through the different parts and the different stages. We'll recap what an alpha particle is, what it is that makes nuclei unstable, just to make sure that we can recall that in case you're asked. And then go through the alpha decay equations, which aren't as horrible as they first seem, but knowing you, like, you'll look at it and you'll panic. But don't worry about it. I'll take it nice and easy. And then there's plenty of examples for you guys to have a go of. So let's start with reminding ourselves of what happens or what causes a nuclei to become unstable. So there are two reasons why a nuclei is unstable, and that is because of the following. So nuclei unstable because either one, the proton and neutron ratio is too large or too small, or the other reason is that because the nuclei is too large for that strong nuclear force to hold it together. And hopefully you'll remember that that's any element, either bismuth or above. So bismuth or above. I say above, I know it's not really above, but you know what I mean. Anything bismuth and beyond, if you like. Okay, so that's a little recap on what causes the nuclei to become unstable. So now we're going to look at what happens when unstable elements want to become stable. So when something is unstable and it wants to become stable, it starts to give out this radiation. So to go from unstable to stable, we start to give out some radiation. And that radiation will be in the form of energetic particles. Those energetic particles, yes, you've probably already guessed it, alpha or beta particles. So alpha or beta particles. And then we give them out, and then the nuclei will eventually become stable. So just to recap again, and this is the last little bit of recap I'll do now, and then we'll move on to actually getting stuck into what alpha decay is. But just to recap very, very quickly, our alpha particles, what are they and what are the beta particles? An alpha particle is otherwise known as a helium nucleus. So that consists of 2 protons and 2 neutrons. And if we were going to write that out, I would write it as an alpha symbol every time I draw these. They look different. An alpha symbol, 4 up here and a 2 there. So it tells me it's got a mass of 4 and it's got an atomic number of 2. And this will become very relevant in the equations in just a little while. And then I'll just move my paper. We're just going to go over beta particles. A beta particle is just a high-speed electron. Symbol for that, literally E minus, or you might want to draw it as a circle with a line in, a minus symbol. And then when we draw a beta symbol, it's a B, 0 mass. And this makes it look like it's got a -1 atomic number, but it's not, it's atomic number. And I think this is where people were getting this a little bit wrong in the previous task. It literally is just represented as a -1. And again, that will become very relevant when we do the beta decay equations. Okay, so that's just a tiny little bit of recap on nuclei, why are they unstable, what happens when they want to become stable, and what an alpha particle is and what a beta particle is. And I'm going to stop this video because it's very, very short, I know, but I'm just going to stop this video as a very quick recap. This can be a little starter task, and then we're going to move on to what happens when the radiation is released in the next video. Thanks.